Hello, everyone. Today, I'll talk about a paper on the memory capacity of visual objects by Lemon and colleagues. There are 4 experiments in this paper, but I will only focus on the most critical one and leave the 3 control experiments out. To begin with, our visual experience of the surroundings seems rich in detail, just like the image here. However, we are surprisingly poor at detecting changes from even the simplest objects. In a typical change detection paradigm shown in the figure here, participants first see an array of objects, which is the original array here, and then a blank screen interval, and then they see the second array, which contains one object that's different from the original. What was typically found was that participants would not be able to detect the change if there are more than 4 objects in the array. The exact mechanism behind this detection failure is unclear. However, there are 3 possible explanations. The first explanation is that no matter how many objects in the array, participants could only capture and memorize 4 items from the original array. The second explanation is that participants might be able to capture more than 4 items. However, this memory was overwritten by the test array representation. And the third explanation is that the large capacity memory of the original array did not get erased by the test array. However, the comparison between the original and the test array, each with more than 4 objects, is effortful. So, the aim of the current experiment is to test the capacity and persistency of visual memory in the change detection paradigm. That way, they can investigate the mechanism behind change detection failure. For methods, here is the change detection paradigm used in the study. First, participants view an array of 8 rectangles in either horizontal or vertical directions. This is followed by a 1600 millisecond of blank screen interval. And then they view the test array, which was either identical to the original array, which means there's no change, or contains 1 rectangle that switched to a different orientation. And participants made button presses to indicate whether they detect a change or not. In most of the trials, a cue was presented to indicate the rectangle that is likely to change. And participants were told that the cue is the key to change detection because if there is a change, then the cue rectangle is the rectangle that changes. However, if the cue rectangle does not change, then there is no change in the trial. And the timing of the cue presentation varied to test the capacity and persistency of people's visual memory. So the first cue timing is to present the cue during the original array presentation. Because the cue is the key to change detection, observers only need to memorize the cued rectangle to decide whether there is a change in the trial. The second cueing condition is to present the cue at various timings during the interval. In this condition, what participants need to do is to retrieve the cue rectangle from their memory of the original array before they see the test array. And then they make the comparison between the remembered rectangle and the respective rectangle in the test array for change detection. And the third condition is to present the cue during the test array presentation. In this condition, participants need to retrieve the cue rectangle from the original array, the memory of the original array, while they're seeing the test array. And there's a baseline condition where there's no cue throughout the trial. The outcome measure they used was item capacity at each timing of the cue. This measure incorporated the raw change detection accuracy of participants to estimate the number of objects from the original array that are available in participants' memory at the time of the cue. And here is the results. The x-axis is the timing of the cue from the beginning of the interval. and the y-axis is the capacity. And as I mark out here, people's capacity remained above 6 during the original array presentation, the black bar here, and as well as the interval, which is all the gray bar here. However, the capacity decreased significantly when the test array was presented, which is the black bar at 1800 milliseconds. For discussion, our results show that people have a large capacity memory of objects from the original array, more than 6 out of 8 items, after they see the original array. This argues against the hypothesis that people could only memorize 4 items. And secondly, people have a large capacity memory of the original array, but it decays substantially when they see the test array. This argues against the hypothesis that people's original array memory was still persistent when they see the test array. And finally, the results gave support to the argument that the original array memory was overwritten by the test array representation. The results imply that the capacity of our moment-to-moment visual experience is larger than previously estimated, but this memory is fragile as it would be overwritten by new inputs. The remaining question here is that how much does our perception of simple objects say about our perception, this rich perception of the surroundings? Is there anything over and above simple shapes and orientation and colors when we see our environment? This encourages future studies to replicate experiment using natural scenes. That's it.